Thanks for coming today. We'll be talking today about driving AWS cost efficiency at your company. My name is Bill Lynch. I run the products team at Cloudability. And obviously, we have a perspective on this, and I'll be sharing a lot about what we've learned over the last almost 6 years of doing this, keeping it at a high level, and talking about some techniques that we think are really great in order for driving cost efficiency. So, to specifically what to expect from this session, we really want to sort of shift people's talk and thinking away from just cloud costs to measuring and acting on cloud efficiency. In our opinion, cloud costs are things you have. Cloud spend's what you do with them strategically for your business, and cloud efficiency is the measure. And we really want to think about moving everybody to managing to cloud efficiency and how to drive to it and what you can do at your business to get started. A little bit about myself. As I said, I'm the VP of Product at Cloudability. Big cloud fan. I've been following S3 and AWS and EC2 since it launched 10 years ago. Really looking forward to seeing a AWS snowmobile charge come through for one of our customers, and eager to write a report to show somebody that. All right, so there's a lot of different aspects of efficiency, and let's dive into what we actually mean when we're talking about cost efficiency. So to illustrate some of this picture, I want to start with a picture, an unrealistic picture of cloud costs. When you're looking at cloud costs, you don't, usually you're looking at some measure of usage, some measure of price and costs. The blue bars here in this graph represent usage going up over roughly 2 years, anonymized usage data we've seen from a customer or two. And cloud costs are going up in the early days, tracking above usage. The actual specific numbers aren't exactly relevant, just the fact that it's trending higher than usage. And then somebody does some work, does some cost management, and then boom, costs go to virtually zero. I think if we were all this good, we would be the ones giving reInvent. And obviously, you guys are not here because this is your expectation. You're here because you're going to spend more money on cloud. And the choice is you can feel really bad about that or feel really good about that. And there's a way to measure this stuff that turns it away from, oh my God, I just spent $100,000 on AWS, to I spent $100,000 and got $300,000 of value out of it. That's where the conversation really needs to shift. So this is an unrealistic picture of cloud costs. I'll show you a more realistic scenario in a minute. But an important other factor in measuring cloud costs and efficiency is considering timing. And when efficiency actually matters is a really important part of knowing when to manage and pay attention to this stuff. So same graph, roughly same level of usage, no crazy spike to the bottom of zero costs here. But the blue bars, usage, could be EC2 usage, could be overall usage. Again, the specific numbers aren't as important as the trend. Going up and to the right, costs going up, fluctuating down a little bit, going back up. And I'd like to call your attention to the top 3 labels there. There's really kind of 3 different trimesters of this journey that somebody was on. First, they started off developing new products, and maybe if you're in IT and you're already an established company, it's starting new cloud projects. If you're a startup, it's literally starting from ground zero. And at that point, cost efficiency and running things and maybe even not even having a CFO, it just isn't a priority. Your priority is to develop new products, experiment, iterate, move as quickly as you can. And then as you start to grow into the second trimester, that's where you probably start to think about getting a bit more cost sensitive. You're trying to, as you're working out your business model, as you're establishing, running your applications at scale or in production, this is where you need to start to pay attention a bit more to costs. And certainly on the third trimester, when you're actually scaling and running serious workloads of longevity or delivering apps to your customers in a scalable fashion, long-term way, that's obviously where not only the costs are important, but I would think of it more of the economics are extremely important. In this case, costs were going up. Somebody did some work, costs started going down, but then they started going up again. You think and more in line with where usage was, which is a good thing. But in general, I'd like to introduce another kind of usage or another kind of measure of this, which is a rough unit cost. Essentially, a more economical view of cloud costs. And ultimately, especially as you get through that second and into the third trimester, you're going to want to look at these economics instead of just raw costs, because this is really the language that you need to be thinking about cloud. Cloud's all about moving quickly, building products as fast as you can, but ultimately that has a business impact or it doesn't, and you care about that or you don't. And in this case, even though cloud costs will be going up in this scenario, the orange line, the green line shows a downward trend among cloud around unit costs, which is the important measure. High-level concepts, but I think you probably understand there's a different measure involved there. So that's some of the financial picture of it crossed with usage. Let's actually get into some of the actual technique areas. So we see a bunch of different elements of cost efficiency if you really split it apart. There's usage efficiency, which is, do I need to use a resource, and is it the right time for that resource? There's cost efficiency. We also call this rate efficiency, which is, am I paying the best rate for that workload? There's utilization efficiency, which is, given that I needed to use that thing and I paid the least for it, is it actually providing me business value? And then finally, one that we think is a little overlooked sometimes, which is organizational efficiency, which is how quickly can your business move? How quickly can you make decisions, especially involving economic decisions around your cloud cost? We see a lot of companies that are really stymied in their progress because they don't know what an RI is, or they don't have any way to base the business value of a cloud cost bill. We'll talk a little bit more about that one, all of these in depth, but that's sort of one that's near and dear to my heart. So, of course, these things all interrelate. Usage informs cost, informs utilization, which informs usage. And what we mean by that is, we think that a lot of the optimizations you typically do around cost are downstream from things like usage. One of the best cost optimizations you can do is deciding to not use something, and I'll talk about what that means to not use something. But with the cloud, you obviously have that benefit. It's way different than buying a bunch of servers and sticking them in your basement. That's a sunk cost. Cloud cost, as you all know, variable cost. So are you usage efficient? If you don't need to use it, you turn it off. But once you decide you need to use it, are you paying the least for it? If you're paying the least for it, are you getting the most out of it, which is utilization? And then if you're not getting anything out of it, or you can do something different with it, that informs usage. In other words, it's a measure of, do I need to use that thing? So it's a virtuous circle. And of course, in the middle is your organization, informing the decisions, helping you move as quickly as you can. So we're going to dive into each of these 4 areas, starting with the usage. Have a bit of a cold. Vegas isn't the best place to recover from a cold. Okay, usage efficiency. As I mentioned, usage efficiency is determining whether or not you need to use a resource, broadly, a resource, an hour compute, a Lambda function, a database table, whatever else. We really believe all other optimizations can be downstream, right? Why bother cost optimizing something if you should probably focus your time on developing a more elastic environment? So let's figure out some of the ways to measure usage efficiency and some of the ways to affect that. And I'd like to introduce a concept that I think would be useful when you're talking about this stuff with the rest of your teams and your company about usage versus usefulness. And to illustrate that, let's look at 2 different services here. Amazon EC2 and AWS Lambda. So obviously, we all know what EC2 is. Happy birthday, EC2, 10 years old. Generalized compute, useful for lots of different use cases, of course. Lambda, way more specific, purpose-driven functions, no servers, about 2 years old. The picture I always have in my mind is like an infinitely useful Swiss Army knife. I wish this was a real product that I could actually buy on Amazon.com. But anyway, it's infinitely capable, and as we saw yesterday in the keynote, there's a bunch of new instance types, and this isn't going anywhere. By usage in dollars, we see this as still the most used service out there. So there's a lot of ways to improve it, and obviously a lot of use cases. Lambda, on the other hand, very purpose-driven, very singular focus with that. And the point in illustrating this is that anybody knows you can turn on an EC2 instance and you're using it. You're going to be billed for that hour, whether you do something useful for your business or not. That's what we mean by it's being used. It's not necessarily useful. And so the optimizations you want to think about is like how much of a gap do I have in my workloads about them being useful for my business? I would argue that AWS Lambda, because you don't pay for it at rest, you only pay for it when you're actually using it and invoking the function, there's a much, much smaller gap between it being actually useful. In fact, the odds are that it's most likely going to be useful inherently. So when you look at usage efficiency, there's a level of picking the right service and picking things that are inherently more optimized to be useful, in other words, closer to the business value. A couple different attributes to think about this when you look at the different services that Amazon provides and whether or not they're inherently useful or usage optimized. I look at waste potential and I look at constraints. So As you can imagine, EC2 makes sense. A high waste potential, and I don't want to in any way pan EC2. It's a great service, and obviously a lot of us are using that. But as I just said, it's possible to turn it on and 100% waste its time and money. The constraints are very low. You can do basically whatever you want with it. AWS Lambda, on the other hand, exact opposite. The waste potential is very low, I would argue, because you can't really do anything with it other than write functions and execute blocks of business logic, and therefore the constraints are meaningfully high. The payments obviously are different. You're going to pay by hour for EC2 and by usage for Lambda. So again, we'll come back to a couple of these attributes to compare other services, but this is how I tend to think about these different services and whether or not there's a gap between being inherently useful or usage optimized and being useful. So another way to look at this too is service usage efficiency. And the graph on the left is probably what all of our spend looked like 5, 6, 7 years ago, mostly EC2. That was when we were running MySQL databases on EC2 before RDS, and where 100% of your spend was going to be occurring in just generic compute. Likely usage inefficient, again, not to pan the service, but again, there's lots of room for optimization there. Over time, as AWS has introduced more services, the picture of most people's compute looks something like that on the right. Let's call it half general compute EC2 usage, with the rest of it being split up with a number of different services. So RDS, Lambda, Elastic MapReduce, Redshift, ECS, the container service. Just by simply moving to these other services, we consider this an optimization. We consider this a cost benefit, because you're spending your money on something that's much more purpose-driven. And of course, there's the fuzzy math of just the value of your organization of having somebody else, for example, take care of your database or maintain and automatically load balance your Lambda function. And obviously, in the left picture versus the right, you have a smaller piece of the pie in which to go and cost optimize. So if you're going to go buy RIs, you can, if you have a plan to transition some of the MySQL databases you're running on EC2 to RDS, then obviously you don't need to be buying RIs for those EC2 instances. So we really encourage you to look at transitioning, if you haven't already, and increasingly taking use of new Amazon services, because they're going to be inherently more service and usage efficient. Back to those couple of constraints. So the waste potential and the constraints. Some of these ways to look at the different services will inform the strategy you pick when you want to go and actually optimize the different services. Obviously with EC2, I already talked about that, high waste potential, low constraints. The strategy you're going to want to employ to optimize that block of compute would be optimizing its cost, optimizing its utilization, making sure you're getting the most out of it. ECS, Lambda, Redshift, and RDS, we'll look at those. Let's look at the bottom up though. Redshift, low waste potential. By that I mean you can't initiate a Redshift EC2 cluster, a set of compute nodes, without it being used for Redshift. And so it's not like you can run other jobs on those instances, those EC2 instances. And the constraints are relatively high. And so therefore you're going to want to optimize cost. You're going to want to buy RIs for that and whatnot. Lambda, same thing, more or less. Low waste potential, high constraints. We'll talk about Lambda cost optimization there in a minute, but that's more about optimizing its usage, because you're not paying for it at rest. So anyway, this is, you could probably argue a little bit about high, medium, low, some of these scores or whatnot. The point here is to illustrate per service, per optimization. It's not as simple as just buy an RI and you're all good. There's definitely things you want to keep in mind as you use these different services when you talk about optimizations and efficiency. Okay. So when you think about usage optimization, you have to think about elasticity. And as I mentioned earlier, obviously that's one of the major promises of the cloud, is to be incredibly elastic. Some workloads, it's not appropriate or not the right business decision, that's fine. But if you're looking for a good measure or a good proxy of usage efficiency, we believe that elasticity is one of those things. And hopefully you can see this chart. Apologies to people in the back. It might be a bit faint, but this is essentially hours in the day and how many instances you're running at a given hour. And you can see this is a mildly elastic environment. The blue line, the orange line shows an improvement upon that, where almost half of the day you're able to turn instances off, and you're able to turn on more instances to cover a small spike in traffic there. Obviously, we really push and believe in architecting and leveraging auto-scaling, the spot market, and then, of course, measuring and setting goals for these things really is fundamental in driving this kind of efficiency. A lot of this, of course, starts with tagging and knowing, which we'll talk about in a little bit, but tagging everything and really determining the usage per team. A lot of this will dictate how much you're spending today, and then what does that look like in the future as you optimize this going forward. But anyway, elasticity, super important. Okay, so those are some of the aspects of usage efficiency. Let's move on to talk a little bit about cost or rate. So cost efficiency is looking at the money. This means you're paying the best rate. I think most people are here because you have some nagging sense there's a theoretical minimum you could be paying for your compute, but you're not achieving that today, or you're not sure how to apply your efforts. What are some of the best ways to get there, and how would you, of course, measure it and stuff? So reserve instances, obviously a massive component of this, especially when you're looking at EC2, but don't forget that Amazon also provides RIs for RDS and Redshift, Elasticache and Dynamo, and especially in the Redshift and RDS case, what Amazon will tell you about RIs first is look for the compute you have that's steady state, long running, stuff that's likely to not be as elastic. Those are great candidates for RIs. And I think a lot of people kind of look at their EC2 instances and say, okay, where can I start here? Keep in mind, RDS is probably a great place to start when it comes to RI management, because it's unlikely in most cases that your database will go up and down. So that's a great place to start. Anyway, I'm sure you're all familiar with RIs, but as a bit of a recap, an RI is not a physical instance. You don't initiate an RI. We think of it as a book of coupons, an hourly book of coupons you can buy for a year or 1 or 3 years. There's 8,760 hours in a year, so imagine you're buying a book of 8,760 coupons. The coupons apply to a set of parameters when it comes to compute, so it's going to be the AZ, the instance family in EC2, the region, of course, and of course the size of instance you want to cover. I'm not going to go into RIs in huge depth. There was a session my colleague gave called ENT202. Definitely recommend you go watch the video. It's on YouTube already of that one. Saving at scale with reserve instances goes into a lot more depth. I'll definitely dive into some of it here, but it's a topic I could probably talk for 2 hours about, and I'll only talk about it a little bit here. But anyway, reserve instances, you can modify them after you've purchased them to better fit your compute. There's a bunch of different flavors now of RIs. I'll talk about that in a second, but in general, really great vehicle to go and reduce your rate. So who has heard of convertible RIs so far? Show of hands. Who's actually purchased a convertible RI? Okay, of the people who purchased, has anybody exchanged them yet? Nope. Okay, so they're brand new. They're 2 months old, or I don't know, 8 weeks old or something like that, or 7 weeks old. So what's really interesting is, obviously some of the attributes of what makes a convertible RI different than a standard RI. But before I talk about those things in depth, the thing to really think about for your business is that there's sort of 2 variables to consider here. Do you want to maximize your savings, or do you want to maximize your flexibility? And there is a way to maximize your flexibility and also achieve a savings rate, but in general, I'll show you the costs of what a flexible approach more looks like. But as you'll hear me say a few times in this presentation, it's not as simple as just buying an RI. Really, the best thing you need to do organizationally is get square on your priorities. Am I running something that's steady state, that's more long-lived, that I can afford to be more aggressive in my savings approach? Or do I have something that I do want to have some savings for, but I need the flexibility down the road to go and change things as still be covered as I change? So standard RIs, these are the RIs we've known and loved for many years. They are available in 1 and 3 year terms and different ways of paying for them. You can pay for 100% of the cost of them up front, you can pay for some of it up front, or you can pay no up front and pay it monthly. But these are tied to specific families of compute instances in specific regions and AZs, if you desire. On the other hand, convertible RIs are a bit more flexible. You can buy a convertible RI to cover an M4 XL, and later you can change it to a C3 XL or to a G2 instance if you want to. So you can actually convert and move around. So as your architecture changes, you can move the savings vehicle along with it if you desire. Parallel or perpendicular to this is the idea of capacity versus utilization. And this is what Amazon introduced in their regional benefit. So it used to be the case when you bought an RI that you would buy it for NAZ, which meant that you tie it to, for example, US East 1A. So if you were running all of your compute in US East 1A, your coupon would apply to that. The moment your compute went to US East 1B, your coupon would not apply to that, and that would count as waste. Now, what the give to get there that Amazon always talked about was capacity. When you're buying an RI, you're not just buying a guaranteed savings rate, you're buying capacity. And so, which means if I want to launch an instance in one of those 870 hours, or 760 hours, 8,760 hours that I bought, I'll be able to do that. If you aren't as capacity sensitive, and you want to maximize utilization, you buy an RI with what's called the regional benefit, which basically takes away the AZ setting and says any compute that you run, for example, in US East, will be covered. Not just US East 1A or 1B, anything in US East would be covered. And so, again, that's sort of the technical aspect of how it works, but again, the business conversation, I think, is a little bit more interesting. Do you care about capacity, or do you not care about capacity? Do you care about maximizing your savings and your utilization rate, et cetera? So these are all conversations that as you're considering buying RIs, you ought to be talking about between the ops and the finance teams to make sure your priorities from your business sense match what you're actually paying for when you buy an RI. And speaking of buying RIs, let's look at some math. So I like looking at an M4XL large. It's about 24 cents an hour. And if you do the math on that, that's $2,000 a year, roughly. The columns here represent the kind of RI term, the kind of RI and the RI term, so 1 year or 3 years. Amazon doesn't offer a no upfront 3-year standard, that's why that's NA. And the rows here are the methods in which you pay for them. So again, no upfront means you buy the RI and you're charged monthly for it. Partial means you pay some of it. All upfront means you pay 100% of the cost of the RI upfront. And as you can see, it makes logical sense. The longer your commitment and the more you put up front, the bottom right cell, that's maximum savings. That's 63% savings rate over on demand, which is about 9 cents compared to 24 cents. The upper left cell represents the more timid approach. Still good though, that's 30% off of about 16% an hour. And so this is a useful way to look at the different costs of an RI, and obviously the 3-year ones are annualized in this example. But the more interesting thing, because these numbers are all compared to on-demand, but I really like this view, which is to look at directly compare the 3-year convertible cost with the 3-year standard cost, and this is the price of flexibility. So if flexibility is important to you, if you want to achieve some savings, but at the same time have the ability to go and modify those savings vehicles to match a changing architecture, in real dollars and cents for an M3X large for 3 years, that's going to be $300 a year. And you can imagine doing the back of the napkin math when you talk about the number of instances you have. You can kind of understand that. So by directly comparing those two columns, you can get a sense of the price of flexibility. So a few more tips for RIs. As I said before, definitely examine the business priorities when it comes to savings, flexibility, and capacity. Use the regional benefit definitely to minimize waste. And again, the way this works is the regional benefit makes your RI apply to the region, not the AZ, which means that as your compute is moving around. So if your architecture is multi-AZ, you may want to heavily look at this because the odds are that you'll be better able to use every single one of those 8,760 hours because your compute's in different AZs. Buy centrally. This is one of the biggest things that I can tell customers, especially when they're operating at scale. So if you're pushing multiple tens of thousands of dollars a month in cloud spend or more, centralizing your spend under one payer is one of the best things you can do, because one of the first things you're going to have is you're going to hit your spending automatic price discounts faster. S3 tiers, other tiers, et cetera. The more compute you have under one umbrella, you'll get those automatic price discounts. But the other aspect about buying centrally is, let's say you have one team using some M4X larges, and they stop using M4X larges. So you've bought this RI, your compute's gone, you're wasting the hours. Well, if you manage more of if you've bought that RI centrally, and if you have other teams using M4s, the likelihood is that RI you bought will be applied to somebody else's compute. And so take advantage of your scale. Buy centrally, look for the most common types of EC2 instances, and the odds are that somebody in your company will be using that long enough for you to get the value of that RI. We think that over time, the optimal savings strategy or savings portfolio will be a mix of both standard and convertible. Again, this is where it pays to know the type of compute you're running. What's very steady state? What's unlikely to change? Maybe you migrated something as an app that's going to stay relatively like it is for a year before you bring up a new thing and transition from that. That's probably a great use for standard RIs. You may have newer architectures that are changing more frequently, might be a good use for convertible RIs. We really don't see anybody needing to be religious about either one of these things. The thing I would say, though, is that with convertible, you can still make some of the same modifications you could with standards. Basically, you do an exchange up or down in different sizes. Again, I won't go into detail on this. Definitely look at the other RI talk for that, but some of the same kinds of techniques for modifications still exist with convertibles. And finally, a big one for basically for everybody in the room, it's really important to understand that as you look at your cost of RIs, you'll have to be amortizing the cost of those upfront payments over the number of hours in the year. If you in ops or engineering haven't done that already, your finance team will ask you about it. They'll definitely be asking you about the big spikes in cost and what those mean, and you want to be working with them to represent your cost as something that's amortized or split over the term of its usage. I know way too much about that stuff as a technical person, but it's definitely something you'll be asked about it from your finance team. Okay, so let's talk about serverless. So one of the most immediate things you're going to notice about serverless when it comes to cost efficiency is just how different it is. Units and language and number-wise. So again, looking at an EC2 M4 X large instance, about 24 cents an hour. Let's compare that to a Lambda function allocated 512 megs of memory running at 8.34 millionths of a dollar per invocation. As an American, this is like going to Canada and buying gas, liter per kilometer. What the hell is that? And it's just, you have no basis. So the back of the napkin math you were able to do in the past is not really possible anymore. And so Werner this morning in his keynote had a really interesting tidbit he dropped about FINRA. FINRA's doing 500 billion Lambda executions a day. So in that case, let's actually do the math. And I wasn't able to modify the slide, but I did the math. And assuming they go for a 512 meg Lambda function at 500 billion invocations per day, that's $417 per day. And that's $12,510 a month. Now, that's a much easier way to compare it to, and then you look at that and say, okay, they didn't have to do anything to scale it out. They didn't have to do anything to worry. I mean, all these things that Lambda takes care of for you automatically, that's part of the value equation. And that's a high number. I mean, 500 billion per day is a really high number. So we think on some level that the serverless will continue to be kind of under the radar for most people in terms of expense for a while, but when you start approaching those numbers, you'll start to see that. Now, the other interesting thing about that example is that I priced that with a 512 megabyte execution environment for the Lambda function. If the engineers make their function twice as memory efficient and you can downgrade it to a 256 meg execution environment, you've saved yourself, it's now $6,500 or $6,055 per month. You've cut it in half. And also if you go down to 128 megabyte Lambda function, you're now looking at only $3,000 a month to run 500 billion calls a day. So what's really interesting in that is it doesn't become so much of a cost, the cost efficiency exercise there is to look at the code, look at the usage optimization of it, and focus on that. But we think that over time, more and more engineering teams will be looking at that and then optimizing their code, which is a wonderful thing to have to optimize, not have to worry about load balancing and whatnot. And finally, the last thought with serverless is that what's going to become really important as more people continue to adopt serverless code is to not just look at Lambda functions, but look at Lambda apps or serverless apps as a whole. A lot of people define their applications with multiple Lambda functions, DynamoDB table, a API gateway deployment or whatnot, and it's going to be important to group that as a functional unit, track the cost of that functional unit, and then if you want to go optimize, you look for the various different levers functionally to change there to optimize its cost. So a bit of a different exercise than looking at just EC2 RI purchases. Okay. Utilization. So assuming you needed to use the thing, and assuming you pay the lowest amount for it, how do you maximize its value? And of course, the term maximizing its value is going to be something that's going to depend on who you are, what your business case is, and obviously goes without saying, measurement is crucial to figure out how to maximize its usefulness. Some of the measures of utilization, obviously, is CloudWatch. We think is a great source for measures of what an instance is doing. Some of the stuff that was talked about this morning is really interesting, and I'm eager to start to correlate those kinds of things with cost to determine value. But in general, out of the box in CloudWatch, you get a lot of metrics available for you. You get CPU and disk and network usage out of an EC2 instance. You get cluster statistics for ECS. All of these things, it's important to correlate with the cost of it and understand, okay, what is this actually doing for me, and is it of value? And of course, you can inject custom metrics into CloudWatch or other third-party tools, and once you correlate those with cost or with the business function of the code you're executing, that'll give you a really good sense of its utilization or of its value. But really, ultimately, a lot of this comes down to, when you look at utilization efficiency, knowing where to focus your costs. This is a quick screenshot of something we've been working on. It's called Efficiency Planner. Actually, it has a different name now. But in general, it's not so much about the screenshot of the application. More of it is that we've, in this case, we were working with a customer to take a number of the utilization metrics, combine them into a score, and then correlate those with the cost. And in English, what we're trying to do is find the things that are performing the worst that cost the most, because that's where you want to focus your efforts. And a lot of this stuff is just telling, basically giving your dev team hints as to know where to go optimize. You want to find those things that are just terribly out of whack. And you can't be presumptuous about a lot of this stuff. I think that our attitude is to shine a light on some of these mismatches between utilization and cost, and rely on the engineering team to do the right thing. I don't think it's possible to really click buttons and solve some of these problems. Some of these things, it might be okay to run a server at 5% utilization as long as there's business value there. So increasingly, knowing what drives value for your company and reflecting that in the metrics and correlating this with cost, it's a huge measure of utilization. So containers are something that we get asked a lot about, and I thought I'd talk a few minutes about that. In general, the questions we get asked about containers are usually, can you cost allocate the cost of an individual container on this cluster? And I would say that it's early days in this area, and that some of the data is elusive. And also, too, that the reason I put this in the utilization section is I believe it's actually kind of more of a utilization kind of exercise. In other words, is your cluster providing you business value? So by comparison, if you look at EC2, the metrics you're going to get out of that are at the host level. And by comparison, an ECS cluster, you're looking at cluster level metrics. The right-sizing action for EC2, you're going to be using auto-scaling groups, many other techniques. And for an ECS cluster, you're going to be growing or shrinking the capacity of that. But what it occurs to us that when EC2, when you're looking at, is this thing I bought and I'm using providing me value, and if it's not, I can remediate it by growing or shrinking the size of it. That's really a utilization optimization. And by ECS, you're kind of examining the entire performance of the cluster and growing or shrinking it as well. And so we would encourage people to think about container efficiency and container costs as making sure that because the container service, in ECS in particular, has a lot of great features that allow you to grow or shrink it automatically. And so really the question you want to be asking yourselves about ECS is, am I getting the value out of it? Is it performing what I need out of it? And am I getting basically the money for the dollars I'm spending on that cluster? So all of these things, I wanted to introduce an example of something that we've been working on with a couple of customers around examining their efficiency, because we get asked a lot okay, efficiency is the measure, then what are the actual stats I can look at in some of these areas? So I want to show you three things, graphed over about a year time range, savings, utilization, and elasticity. And you'll see here some changes in this customer environment. So the blue line represents elasticity. And by comparison, the 0% elasticity would mean that for a given time window, you didn't decommission anything. No instances changed, nothing turned off. 100% elasticity would mean that in a given time period, 100% of those resources had cycled, had done something different, had been decommissioned or turned on or off. And as you can tell, in the beginning part of the year, elasticity was okay, maybe averaged around 5%. But through a concerted effort, this customer vastly increased their elasticity. You can tell even that makes sense, because even like month to month or even week to week, there were certain peaks and valleys in this. But overall, the trend is up with elasticity, which is great. Then we looked at utilization. And for this customer, they pretty much held it steady, which was great. I mean, and we actually looked at this across a number of EC2 instances and kind of mashed it all together in terms of one rough score proxy. But in general, they didn't focus too much on the utilization aspects of it. However, one of the things they did focus on too was savings. So this represents the line of the amount of compute you're running under savings, under some percentage off of on-demand that you're running. And so they were able to get it up from about the 20% range for this level of compute up to almost double in a year of 40% range. So I brought this picture only to illustrate that they didn't focus on doing utilization work. They focused on elasticity, and they focused on the savings rate. And this, for them, painted a much better picture of what their efficiency looked like, and definitely helped guide their efforts as they were going through. Now, you can imagine this is something you could look at across all of your instances, across all of your compute, per team, per application, what have you. So let's talk a little bit more about organizational efficiency. So as you all know, cloud is different than just traditional IT, right? So it's possible to move really fast. And I think the most healthy companies I've seen, the most progressive companies that have moved the fastest, have an enablement attitude about this. It's not about control. It's not about stopping things. It's about moving as quickly as you can, at the same time having the right kinds of information or the right kinds of checks and balances to move quickly. And I think that all comes down to organizational efficiency. From simple things like, does your team, meaning usually finance or people outside of the technical realm, know what an RI is? Do they know what some of these techniques work? One meeting goes a long way to moving quickly. But how fast can you actually make the decisions, and how quickly can you move while managing spend? So to get a little bit more tactical about this, we think that this is a really fascinating and exciting aspect of cloud, in that you have two teams that have traditionally not really worked that much together can work together almost on a weekly or monthly basis, ops and finance. Maybe someday there'll even be FinOps roles out there that people who work in finance but are specifically meant to be serving and working with ops to help them move as quickly as we can. As I said earlier, we really think that buying RIs centrally is a huge aspect of doing RIs correctly. And we really believe this is something that, in terms of, that has traditionally been on the ops or engineering team's shoulders, but we've seen it successfully put in the purview of finance. And once you give them the right tools and educate them, and you have the correct amounts of interaction to have the right checks and balances, we really see a productive behavior when finance or FinOps is able to take on the kind of cost optimization and pull those levers, which frees up engineering to focus on efficiency and utilization kind of work. And a big part of that is having cost visibility at every level. I think a lot of the best cost optimizations we've seen is simply opening up the data to as many team members as possible up and down the stack. You want to look at individual developers having a purview over what their costs are. And we really think that over time, engineering teams, that time is now actually, the engineering teams will be responsible for the operational cost, right? Deliver code that's high quality, on time, under budget or at budget, but also that operates within some parameters that you were able to predict and you're able to manage to. And so that starts with having the visibility at the engineering level. And then when you're interfacing, especially from a technical side or the ops side to the rest of your business, we think that these levels, these measures of efficiency, or especially these measures of unit cost, is the healthy way to look at the costs collaboratively. Remember, likely that your finance teams might freak out if they see the bill that comes in with no context of $200,000. Who wouldn't, right? But presented in a picture of, well, it's $200,000 so we can make 400. We often think, Toyota, when they have to go and order more tires, they don't worry about the cost of the tires because they know there's a direct correlation to numbers of cars they sell. And so getting your company to discuss things in terms of those metrics, in terms of those units, super crucial to moving fast. And obviously, knowing the key performance indicators for each function or for each application you're serving is massive as well. And that's sort of, we see a lot of our role, we see a lot of cost being the numerator, right? Like an accurate sense of your costs across all teams, across all apps. And then it's up to you to figure out what's the important business measure that I divide that by. That's what the unit cost equation is all about. So quick summary to wrap things up here on some of these, on the 4 different major areas. We really think leverage the service usage APIs and services. Just by transitioning away from running MySQL on EC2 to using RDS, that's a huge cost optimization and an investment in a more service efficient future. Invest in elasticity, and then optimize everything else downstream of that. RIs, and again, I encourage you to check out the ENT202 session. Really understanding the language of RIs, understanding the business priorities that lead you to purchase certain RIs, can't emphasize enough. That's one of the best ways to reduce the rate of your cloud spend, especially when you're operating north of several tens of thousands of dollars a month in spend. Architecting for Spot, using autoscale groups, et cetera, huge benefits to cost efficiency. And utilization, that's really all about right-sizing your instances, making sure you have the right kind of workload that's appropriately sized and taking most advantage of the resources you give it, and figuring out what you don't need to use and shutting it off. And finally, I'm a huge fan of organizational collaboration, ops and finance. You can't do this stuff in either side, and you can get a lot of leverage by, especially on the ops side, by training people in finance or people in financial operations to purchase RIs and manage that program for you. So that's a look at cloud cost efficiency at your business. Thanks so much for your time today. I think we have some time for questions. There are a couple mics here, and if not, I can be available afterwards to chat. Thanks.